So, last but not least for chapter 3 is mixtures. And as much as I love distance problems, I like mixture problems probably almost just as well. So, for our lesson openers, we just need to take a look at remembering how to simplify some expressions. So first of all, just distributing. Remember, we have to distribute to the first and last in our parentheses, and always remember to take our signs into consideration. And 15% of 70, remember our equation for percents. Percent times our whole gives us our part. I'm just going to multiply, or always just remember of means multiply. I'm going to change this into a decimal first. We have 15% of 70 is 10 and a half. Then we also need to just look at some translation of word problems. So Kathy has 20 marbles, some blue and some green. If the blue ones are represented by B, how would you represent the green? Think about it for a second. Pause it if you need to. So if she has a total of 20, we know some of them are blue. That would be B. So that means if we wanted to say, well, what's the green equal to? Green would be 20 minus B. Larry is L years old. How would you represent his mom's age if the sum of their ages is 87? Well, we know that Larry's age plus his mom's age equals 87. So if we want something for just his mom's age, just subtract L from each side, or we could say 87 minus L. That would be mom's age. How would you represent the amount of salt in X pounds of a mixture that is 3% salt? This is one that we're definitely going to be using this today. So we have just 3% and X. How would you represent the amount of salt in X pounds of a mixture that's 3% salt? You're just multiplying these two things together. So mixture problems. Mixture problems involve the combination of different substances. Making a table can be quite helpful. So this chapter we definitely use a lot of different tables, so it's good to know how to set them up. These are also really good practical, just life application type skills. You mix stuff all the time, and if you're needing to know anything about the cost of your mixtures or the quantities needed to make a certain kind of mixture, these are really going to come in handy for you. So, example 1 says a feed store owner wants to mix corn and barley to make 150 bushels of silage additive for cattle feed. I hope I'm pronouncing that right. I really have no idea because I'm not a farmer, but we get the picture. If corn costs $3.80 a bushel and barley costs $2.60 a bushel, how many bushels of each grain would he mix to yield an additive worth $3 per bushel? So, we know that the number of bushels multiplied by the price per bushel will equal the cost. That's just kind of average, I like to call it shopping skills. So your quantity of whatever you're buying times the cost per unit equals your total cost. The cost of corn and barley added together will equal the total cost of the mix. And when we say the cost, this is the total costs. So, for our chart, before we get started on our chart, we need to talk about our variables. So we're talking about the number of bushels of corn. So we're going to let C be our variable. So we always need to establish what our variable is and what it actually represents. So C is our number of bushels of corn. And we're also working with barley, but we want to stick with just having one variable for now, till like way later down the road in chapter 7 or 8, I think. So just stick with one for now. And remember, this is like we talked about at the beginning, with the marbles being blue and green. Well, if some of what we're doing, the corn, is our C, and we know we're going to have 150 bushels total, then our barley can be represented by 150 minus whatever our corn bushels are going to be. So 150 minus C, this expression right here, that's going to be our barley. So let's fill in our chart. We have our number of bushels. We have our price per bushel and our total cost. Remember we said whatever our item is times the price equals our cost. And that's where we got these labels from. So corn cost $3.80 per bushel and barley cost $2.60 per per bushel. And our goal is to have a mixture that costs $3 per bushel. So we have corn, barley mix, and our prices that we know. Now we know that the number of bushels is going to be C for corn, 150 minus C for barley, and that gives us a total when we would add these together, because C plus a negative C would be 0 and 150 would be 150. Our total mix is going to be 150. When we add this column up, it gives us 150. Then we're going to multiply straight across, because we said the number times the price equals our total cost. So 380 C, 150 minus C times 260 or 2.6. And we want our total cost to end up being what? Do we know yet? No. We need to go ahead and multiply these across. So we have 150 times 3, and that gives us our 450. So again, we were just multiplying straight across our columns to get our totals in the total cost column here. And we know that when we add this cost, the cost of our corn, plus the cost of our barley, that's going to equal the cost of our mix. So that's our final equation. 380C plus 2.6 times the quantity of 150 minus C equals 450. And then we can use that equation to solve. So we'll distribute our 2.6 to our 150 and our negative C. Combine our like terms. So we have 3.8 and a negative 2.6 C. That gives us 1.2 C equals 60, because we also, in the same step there, they're catching on that we know how to do this now. So they're just throwing things together all over the place. They also subtracted that 390 from each side, which gave us 60. We divide each side by 1.2, and you get C equals 50, which means we're going to have 50 bushels of corn. Well, then we have to remember that barley was represented by 150 minus C, or 150 minus 50, which means we're going to have 100 bushels of barley. Then you should always go back, check your answer, and make sure that it all works out. Example 2. So nickel, silver, often used for coating tableware, is an alloy containing 15% nickel along with copper and zinc. How much pure nickel will be melted with 70 pounds of nickel silver to make an alloy that is 20% nickel? Whoa. First of all, we need to know that when it says pure nickel or pure anything, it's 100%. So throw that in your notes. Pure substance equals 100% of that substance. So we're going to take our pounds of metal times the percent of the nickel, and that will equal the pounds of the nickel. So pounds of metal times nickel equals pounds of nickel. The alloy is a combination of nickel, silver, and pure nickel. So they throw extra things in there that we don't need to know. Like we don't need to know about the copper and the zinc. We just need to know nickel, silver, and pure nickel. And we're going to say that P is the number of pounds of pure nickel. So P is our pure nickel. So let's go ahead over to our chart. So first of all, we have nickel silver, and they told us that nickel silver is 15% nickel. We know that we're adding pure nickel to it, which we said all pure substances are 100% of that substance. So pure nickel is going to be 100% nickel. And we know that our target, they call it an alloy. A lot of times for this bottom line, I just write this is our goal. So our goal is to have a mixture that is 20% nickel. Then, we know that we are starting out with 70 pounds of nickel silver. We don't know how much pure nickel we're going to have yet. That's going to be P. And we know that these two weights have to add up together, because when we're adding them together, that's how much we're going to end up with in our goal. So that's going to be 70 plus P, adding straight down our column, so just 70P. Then remember, our percents should be written as a decimal. So if you wrote them as a percent, just go ahead and switch them over. So there we go. Remember, 100% is just the number 1. We're just moving that decimal place 2 places. And then we're going to multiply straight across our rows to get the pounds of nickel. So we have 15% times 70, 100% times P, and 20% times the goal weight, or the 70 plus P. And then once again, we know that adding straight down the pounds of nickel, oops, my plus sign goes there, that's equals, this will be our final equation. So we have 15% times 70 plus 100% times P equals 20% times 70 plus P. And we can use that to solve. First things first, get rid of our parentheses. So we're going to multiply here and distribute over here. We get 10.5 plus P. We just dropped off this 1 because we know anything times 1 equals itself. Then we get 14 plus 0.2 P. We need to get, well, we don't have to, but we're going to go ahead and get rid of our decimals just because it makes it a little bit neater to work with. So we only need to really eliminate, they're going to multiply actually by 2 decimal places everywhere, so we're multiplying everything in this whole entire chunk by 100. So we're multiplying the 10.50, the P, the 14, and the 0.2P. Technically, we should be doing this on each side of the equal sign. So we distributed that 100 because we did it to this side. We also did it to this side. So we have equal values still. This is an equivalent equation, I guess we could say. Now we can go ahead and move. So we have our P's on the same side. So we'll subtract 20P over here and 20P over here. And then we'll also want to get our constants on the same side, so we'll subtract 1050 here and subtract 1050 here, which leaves us with 80P on one side and 350 on the other. Last step is just to divide by 80 on each side, and we get P equals 4.37 pounds of pure nickel. So let's just ask ourselves real quick, did we answer their question? They said how much pure nickel must be melted with 70 pounds of nickel silver to make an alloy that is 20% nickel. Yes, because we said how much pure nickel do we need? We need 4.375 pounds of pure nickel. And then if you look at page 136 there towards the middle, you can see that they did check it and it does work out. So just a quick review, solving mixture problems, read the problem carefully, plan a strategy. Remember, when you're planning, you should always assign your variable value so you know what your variable stands for. Like we said, the last one was P for pure nickel. We need to solve our equation, and then always, always, always go back and check your answer. So that is actually it for this section also. They have a couple samples where they have already set up, you're just multiplying straight across like you were practicing setting up a chart and the different rows in a chart, and then there's a good many word problems in here to get you used to doing these. So go ahead and take a look at your assignment and let me know what kind of questions you have. Oh, and congratulations for making it through Chapter 3.